Hi everyone. So we are continuing our second part of solving quadratic word problems. Okay, so this is the same word problem from the video from yesterday, and we're asking different questions, and I'm going to show you how to answer these. Again, my printer is broken, so I hand wrote this. Okay, so a model rocket is launched from the roof of a building. Its flight path is modeled by h equals -5t squared plus 30t plus 10, where h is the height of the rocket above the ground and t is the time in seconds. Okay, so what's really important here is we need to figure out what they're telling us. What are we even talking about? We are talking about a model rocket or a rocket, okay? We're not talking about a ball or a frisbee or whatever. We're talking about a rocket, okay? And what else is really important here is the actual equation, okay? H equals -5t squared plus 30t plus 10. And let's go ahead and just rewrite it right here in this blank space. So h equals -5t squared plus 30t plus 10. Okay, and if we're ever confused, our h is also like our y's, equals -5t is like our x squared plus 30t is like our x plus 10. Okay, this is how what these letters and these variables mean in what we usually talk about. So h, and they're represented like h is the height, and that's why they're using h instead of y, and t is time, and that's why they're using a t instead of an x. But just so you know in your head that that's essentially what these pieces mean, okay? So number one, let's get into the question. What is the initial height of the rocket? Initial and height. Initial. Where did it start? Where did it begin? And where did what start or begin? Our height. And our height is like our y. And when we see starting and beginning, we know we're looking for our y-intercept. Okay? So in looking at our formula they give us, we see that it is h equals -5t squared plus 30t plus 10. And like I explained in our last video, our c is our y-intercept. Okay? So, we know that the rocket's initial height was 10 feet. Okay? It was 10 feet. And like I showed you in our last video, when we are trying to find our y-intercept, and if we forget that it's our c value, when we're looking for our y-intercept, we always set x equal to 0. So if we're taking our equation, h equals -5t squared plus 30t plus 10, and we also know that t means x, we're just plugging this 0 in for t. Okay? And we would know it's h equals -5 times whatever t is plus 30 times whatever t is plus 10. And we determined that our t or x is 0. I'm going to put those into the blanks. And let's put it into our calculator. -5 times 0 squared plus 30 times 0 plus 10. And we get 10. So h equals 10. Okay? Just like it is right here, 10. Okay? And if we were to write this as a point, that would be 0 because x is 0 and our y is 10. Because this is x and this is y. Okay? Now, number 2. How long is the rocket in the air? Okay? So now, let's think about this. Okay? So we kind of know that, all right, let's figure this out, okay? So we know that our equation is h equals negative 5t squared plus 30t plus 10. So how long is it in the air? So we're talking about how long is time, okay? So if we're thinking about this on a graph, we know that it probably looks something like this, okay? Because it's concave down, because it's got a negative as our a. So we're essentially looking for how long, because this is time, from 0 to this point right here. So we are looking for that. How long? How many seconds? 1, 2, 3, 4, whatever it is. We got to figure that point out. So when we are looking for how long in the air, this point right here, we are looking for our roots, our x-intercepts, our zeros, okay? Another word that you might see, like when does something hit the ground? So how long is it in the air? Okay, so what we're going to do is we're going to find it in Desmos, okay? Because there's a video on finding roots, but I want to show you in Desmos, okay? So I'm going to put this just like this down here and show you, okay? So we opened up Desmos, went desmos.com, and then right here, I'm going to type in our equation. So we know it is y equals negative 5 x squared plus 30, plus 30, sorry guys, I'm trying to type this, 30, there we go, x plus 10, okay? All right, so that it's in there. Now, okay, perfect, right? So let's look at this. So we're seeing, oh wow, this is our graph. If we keep zooming out, it's like, wow, that's really, it went really high up there, right? So let's start back. Let's go back to where our graph is. I lost our graph. Sorry guys. There we go. So there's our graph. And let's see, how long is it in the air for? So we have these 2 points as our roots. And let's go ahead and just write both of them down. Because, we got our graph, and there are x-intercepts, and look, you just tap it, and you have it. So our x-intercepts are negative 0.3170, and what's this one? 6.3170. Okay, I just wrote them down real quick. We'll come back to Desmos in a second. So we know that this root right here is our negative 0.317 comma 0 point. Now can we have negative time? Because x is time and y is 0. No, we cannot. So we're going to x that out. And we know that this point is 6.3170. Can we have positive time? Yes, we can. So from 0 to here, that was 6.317 seconds. So the rocket was in the air for 6.317 seconds. And that is your answer. And if we want to check our y-intercept, we said it was 10 up here. And let's just go back to Desmos, just check. Here's my graph. Let's see. Let's look at this point right here. 0, 10. Perfect. 0, 10. We got it.